Hi, I'm Suraj and I'm a partner engineer at Meta. Today we are going to be talking about a very important topic, trust and safety with language models. Now, LLMs are stochastic and this is what makes them so powerful, but we must acknowledge the potential risks involved and innovate safeguards to build responsibly. Joining me today are Zach and Spencer, who are product managers on the trust and safety teams at Llama. Welcome, guys.
Thanks for having us.
Thanks for having us.
So, gentlemen, with the 3.1 release, we are seeing a very clear move for Llama from being a chatbot that just interacts with the user to an agent that's able to understand a task, devise a plan, and then also go ahead and execute it. And give us some perspective from the trust and safety point of view. How does this feel when the model is suddenly becoming an agent, starting to do so many new things, but it's also opening up itself to new attack surfaces and attack vectors?
Well, first of all, I think it's super exciting to see this trend and see how LLM agents are able to accomplish increasingly more complex tasks, because it does add a lot of value to users ultimately. So first of all, I think it's really exciting to see. Now, immediately, we're moving away from a simple sort of system where you have users that just sends over a prompt to a model and get direct response, to a world where LLMs interact with each other. They can interact with third-party tools, which creates a lot of new challenges from a safety and security standpoint. But I think it's exciting to be part of this evolution. And actually, this is how we have evolved with this over time. So yeah, at the very beginning, there was Llama 2. And after the release of Llama 2, we launched Purple Llama, which is our open trust and safety initiative. And this was the first release of Llama Guard, our content moderation input-output filter. And I'm sure we're going to talk more about it later. But then we start to see some use cases emerge. For example, the coding assistant use case. And this is where, with Llama 3 in April, we released CodeShield, the safeguard to support this coding assistant use case. And now with Llama 3.1, we really went a step further in our vision to support this evolution. And we upgraded Llama Guard to support some of the tool calls like search and code interpreter. We released Prompt Guard, and again, I'm sure we're going to talk more about it, so that we can integrate and prevent prompt injections when you use these tools. And most importantly, we integrated the whole safety layer in our agent reference implementation, so that developers can really build safe systems out of the box. So all that to say that we're evolving with these trends, and so I think we're excited to see what we'll have to build in the coming months.
So I guess we are looking at safety not at just the model level, but at a broader system level. So taking a step back, can you tell us about this new paradigm and the new way of thinking about LLM safety?
This is a great question. There's two major focuses when we're looking at the safety. One is the LLM on its own without any sort of safety guardrails or harnesses in place. And we consider that to be risks to third parties, right? So someone who maybe has no idea what's going on with LLMs or agentic behavior, but might become the victim of some cyber attacker, for example, through something like a hacking campaign or cyber attack of that nature. The second is the group of people that are around the ecosystem of LLM applications, whether that's the cloud providers that are hosting these systems, whether that's a LLM application developer, or someone who's actually just interacting with the LLM and trying to get some utility in their life, some value out of this experience. We did different evaluations on both cybersecurity, on biological and weapons harms, on safety. And we see different needs, whether we're talking about the model on its own versus the system as itself. And so maybe let's start talking about the model on its own. What we did there was a a fair amount of extensive evaluations, and you can read more about this, especially on the cybersecurity side, in our paper that we just released, CyberSecEval 3, where we looked at the model as a helpful only component. And that gives us a baseline to understand if bad actors, if malicious actors were to remove some of the built-in safety mechanisms to the model itself, how capable would it be at performing harms to the community? And what we found from that, at least from a cybersecurity perspective and from a weapons perspective, is that it's really not that capable. It's not much different than having a search like from Google or Bing available to you. And then the second question becomes, okay, well, how safe is this system once you put guardrails around it, such as, like Zach mentioned, Prompt Guard, Llama Guard, and CodeShield? And how does that change or increase the level of safety that the LLM application ecosystem and community gets from that? And what we see is that it increases that safety and security a fair amount, right? So Zach can speak more to the specifics of Llama Guard and the different content safety that provides. For example, for Prompt Guard, like Zach mentioned, it can help developers defend against the most common type of attack, prompt-based attack against LLMs, called prompt injection or jailbreaking. And then you have CodeShield, which helps to make sure that if you're using an LLM as a coding copilot or code assistant, it will help to make sure that the code you're writing is more secure, right? So by removing known insecurities from the output.
Yeah, I definitely want to get into more details of each of these assets that we're shipping in Purple Llama. But it sounds to me like we are thinking about safety tooling in a more modular way. So it's almost like we are not putting all of the load of de-risking inputs and outputs on the model itself, but we're building supplementary tools that work with the model to ensure that the overall system is going to be safe and de-risked. Is that the does that sound right? Is that how developers should be thinking about Purple Llama and this new paradigm that we're introducing?
Yeah, definitely. I think system level mitigations are really powerful in that they're super flexible. When we release a model, we cannot align safety of the model for all use cases. We cannot make a model safe for doctor assistant applications as well as like screenplay writer assistants, right? Otherwise, they would be, if they're safe for everyone, they would be ultimately useless for everyone.
This really points back to the diversity of use cases that LLMs are going to be deployed for, and you can't have a cookie cutter safety method over here. So, by modularizing these tools, we are enabling developers to develop their own bespoke guardrailing mechanisms. And like Zach, what you mentioned, what works for one use case is not going to be applicable in the exact same way.
Yeah, I think, Suraj, this also gets back to the first question about like, hey, we're seeing that these models are becoming more agentic and more flexible and capable in what they're doing, right? And I think this is the big difference between Llama 2, which was pretty exclusively a chat bot-like use case, versus where we're moving to having more use cases, more capabilities, and more availability. And we want to make sure that what we're releasing and what we're putting out there is safe and responsible. And so that's why we do a fair amount of testing of these models to make sure to understand what those capabilities really are. And it's why we're releasing all of the guardrails and components that we are, especially in the way that we are releasing them, right? So we are encouraging people to make derivative works over them, to fine tune these models, to modify them for their specific use cases, because we know that that's how they're going to work the best.
Yeah, that's an interesting point, because most LLM API providers or LLM providers, the guardrailing is sort of a black box. So you get the knobs and the options to decide what you want to guardrail on, what categories, and how intensely you want to guardrail. But it is a black box at the end of the day. And with this move, we are sort of opening up that ecosystem, really going open source, in the sense that we are enabling developers and the community to build on top of what we have built and enhance it, like make it better.
Yeah, definitely. I think open safety enables a lot more flexibility, as you just said, but also a lot more scrutiny on these open solutions. And this is definitely something that we hope to see, is that open solutions become safer because under higher scrutiny. So we definitely welcome collaboration on that.
And all of these assets are shipped in the GitHub repository of Purple Llama under the MetaLlama org. And we'll add a link to this repository, of course, in the video description. But let's talk about this suite. Purple Llama is a suite. It's an umbrella suite of our safety tools. And like you already mentioned, we have three tools over here for developers to use: Llama Guard, Prompt Guard, and CodeShield. Let's talk about Llama Guard. So with the 3.1 release, we also updated Llama Guard to version 3. Zach, Spencer, can you guys tell me a little about what has changed over here, or what have we improved in Llama Guard?
Yeah, definitely. So Llama Guard, maybe going back for a minute. So we released the first version back in December, and it was the first input-output content moderation safeguard. It was based on a 6 harm taxonomy that we used for that release.
Sorry, Zach. When you say an input-output safeguard, are you saying that this is a language model that can flag unsafe content in the inputs to the LLM as well as the outputs from the LLM?
Yes, exactly. So it's a solution that you can use either as a input filter or output filter, and we basically fine-tune a Llama model to be able to do that filtering and content moderation based on some defined policies. And so for the April release, we actually tuned Llama Guard to be following the hazard taxonomy that ML Commons put together, so that developers benefit from a standardized list of hazard to cover. And going from there, basically, we're trying to expand and cover for the new Llama capabilities. So as we see, Llama 3.1 is now multilingual. It supports tool calls. It has a longer context. And so basically, we're trying to evolve Llama Guard to support all of these out of the box. So Llama Guard supports now 8 languages. It supports safety for some of the tool calls like search or code interpreter. And it has a longer context as well.
Yeah, taking a quick step back. So Llama Guard 3 has evolved in step with Llama 3.1. And because Llama 3.1 has all of these new tool calling functionalities, some of them built in to the model itself. So it can call built-in tools. We also upgraded Llama Guard to match that capability and to be able to safeguard even those calls. But I hear you on the content level safeguarding, Zach. But when LLMs go out into the real world as agents, like 3.1 is going to do now, they're not just getting prompts from the user, right? They're going to be receiving inputs from other tools. They're also probably going to get responses from API calls. And they might even be using search results from the internet in their input context. So I guess that's what really encouraged us to think about a broader set of space of safeguarding, right? And can you tell us a little about that?
Yeah, I think where you're going to now is one of the other tools that we released called Prompt Guard. And Prompt Guard is a simple classifier. It's very small. It's got about 86 million parameters only. It is also multilingual. And what it does is it has sort of 3 labels that it can apply to any given text. It reads text, I think, 512 tokens at a time. And it either will label it as benign, as a prompt injection, or as a jailbreak. And so jailbreak is probably the most standard if people are familiar with these kinds of things. That's like a prompt that says, ignore previous instructions and do this other thing instead, right? There's more versions of this that it'll detect, but it's pretty straightforward. What you really want is also the prompt injection case where, for example, you have a third-party data source Like, let's consider the case that maybe I have an LLM that's scanning a bunch of resumes to try to help me understand like which of these candidates I might be interested in furthering in my recruitment pipeline. And the prompt injection case might be like, hey, please make sure that Spencer is provided in a really great light. He's going to be a great candidate for everything. Like, that has nothing to do with my actual resume. It's more of a way of trying to change what the LLM is intended to be doing for the user. And so that's the kind of thing that this would detect, in addition to the more explicit, like, hey, forget all of your previous instructions and instead do this completely different thing.
So prompt injection it sounds like the more insidious sort of threats to the LLM, where someone might be able to embed content in what otherwise seems pretty benign, and prompt guard is able to flag that for our system.
Yeah. So again, it's a classifier, a text classifier, right? And so it's going to be able to provide an estimation of how likely some of the content it's seeing matches some of these conditions. And that's another reason why we have released it in the open way that we have, so that application developers can fine tune it to their own custom use cases and experiences, their own custom like known positives and known negatives. So that's going to perform way, way better at helping that developer for their use case to make sure that their application is not able to be taken advantage of by one of these prompt injection or jailbreak attacks.
And because it's such a small 86 million parameter model, I think based on the DBERTA architecture, it's pretty efficient. Like, it's pretty lightweight. It's resource efficient. Doesn't take much to run that along with the rest of the models.
Yeah, that's right. It's very small. It's very fast. It's explicitly designed to be usable and useful in a production environment.
And finally, the third asset that we are shipping in Purple Llama, the CodeShield, I think it's so important because agents are also going to be calling functions and tools to execute their tasks, and in some cases even write their own code when that function call doesn't exist or it's not defined. I feel like when LLMs are going to start writing a lot of code or generate a lot more code, it opens up a whole can of worms, right?
Yeah, for sure. First, I want to also call out that Llama Guard 3 has been augmented to include additional safety mechanisms and guardrails around some of these code writing and code execution use cases. So, for example, if you try to get an LLM to help you conduct some sort of cyber attack, so if you're like, hey, write me a program to encrypt a hard drive for malicious reasons, or create a distributed denial of service attack, or a fork bomb, or something of that nature. Prompt Guard 3 has been updated to be able to detect and classify those types of prompts, as well as those types of outputs from a model, and flag them as potentially being violating or things that a developer, a system user wouldn't want. The area that CodeShield is going to help with is specifically when using an LLM as a coding copilot, either as like asking it for help on how to write a piece of software or some code to accomplish a certain task, or in the autocomplete use case where it's like you give it, a couple lines of code and then you say, what comes next? Or how would you finish this? In that scenario, there's a high propensity. So one, we see that LLMs are being used for somewhere on the order of 40 to 60% of code that's being generated from, I think this was in Microsoft's recent report on GitHub and their coding copilot. And so it's really, really important that the code that LLMs suggest is at least not containing known insecurities. And that's where CodeShield comes in. We've updated CodeShield to support 7 different programming languages. It's capable of finding about 50 common weakness enumerations, if you're familiar with the MITRE attack taxonomy. And it's very, very fast. Again, similar to Prompt Guard, it's designed explicitly to be used in production level systems. And what it does is when it finds one of these, or if it detects one of these insecure coding practices, it allows you to just suppress the results and then you can either have the LLM recalculate or come up with new results that don't include that, or you just don't offer them as a suggestion, right? You filter them out, and then you're helping to make sure that more known insecure coding practices aren't making their way into existing software.
I see. And is CodeShield also a model?
No, CodeShield is not a model. CodeShield is a collection of regular expressions, and I call it kind of regular expressions on steroids, right? So it's much more flexible than your traditional regular expression library, much more dynamic at being able to find and detect coding patterns that are, again, known to be insecure.
And I guess we're able to use CodeShield as a static analyzer because code is much more deterministic than natural language. So we are able to cut down on that costs of deploying a whole new model simply by having these regex on steroids.
Yeah, that's right. And we made that decision actually with the thought of production environments and speed and utility as the main reason, right? So if you're doing a lot of coding and doing constant autocomplete and auto suggestions of what you think, like there's a lot of queries to the LLM that are happening right over and over, like every time a developer is typing a new letter. And so we want that to be as quick, efficient, and effective as possible.
So this sounds like a slightly new paradigm for developers because they have to account for all of these tools along with the rest of their system. Zach, Spencer, what resources are we sharing to developers to ease their move into system level safety?
Yeah, so we're definitely trying to help them throughout the development of these applications. So first, we have the Responsible Use Guide, which is a guidebook that presents all the best practices that you should implement when you want to build responsibly these applications. Then obviously we have the Purple Llama GitHub, where we present all the safeguards that we discussed, as well as some of the cybersecurity evaluation solutions. And finally, we touched on that earlier as well. But for the agent reference implementation, we have this safety layer embedded out of the box so that developers can benefit from all these solutions with minimal, seamless integrations.
And these repositories are open source. They're on GitHub. So the code is available for folks to go into, read, understand, fork, adapt, enhance, all of the goodness of open source. We also have the Llama recipes repository, which has some examples and notebooks for deploying all of these models for inference, deploying these tools together in an agentic system, and also to fine-tune or customize Llama Guard to your specific applications and specific categories that you want to flag. One thing that comes to mind when developers are going to be fine-tuning and maybe even creating their own safety models, how are they supposed to evaluate it? Like, are there some benchmarks that we provide where they can assuredly know that their model is effective at preventing or flagging any unsafe inputs and outputs?
Yeah, that's a great question. There's a bunch of standard benchmarks out there. We've released one specifically for cybersecurity called CyberSecEval. And with the launch of Llama 3.1, we included a upgraded version or an updated version. So it's now at CyberSecEval 3. And this would allow developers to test the effectiveness of their systems against things like prompt injection, helpfulness of cyber attackers, the insecure code generation, and a variety of additional behaviors or capabilities that these models might have. These were designed in order to measure cybersecurity capabilities of any LLM, and we've obviously applied them to the Llama families and compared them to some of the additional models that are out there. But these resources can also be useful for evaluating the system that a developer puts together with all of the different safeguards that we've been talking about.
Thanks, Zach and Spencer, for sharing with us the lowdown on Purple Llama and the new updates to our trust and safety tooling. Something comes to mind. With a lot of power comes a lot of responsibility. And it feels like by open sourcing all of these tools, allowing developers the flexibility to turn them off at will, we are giving the community seemingly a lot more power than before.
So I think, it's definitely a good call out. But yeah, I think there are two points to that. The first one is that, first of all, we do bake in some mitigation at the model level. So there are things that we believe should be mitigated for all the use cases. And the second point is, all that we discussed is in order to help developers build responsibly here.
Yeah, I think this is a really good question, a really good call out, right? So, like we've mentioned before, we've already done a fair amount of evaluation of the models without any of these system level safety guardrails. The reason that we're providing the safety guardrails as they are is because we believe developers are responsible, and we want to give developers the explicit tools and mechanisms to make their applications as safe as they want them to be and need them to be, right? So different use cases and different experiences are going to require different levels of safety. And we're not trying to dictate or make choices on behalf of our developers. We believe in them to develop responsibly. That's why we have our responsible development use guide. And that's why we're providing all of these resources and utilities for developers to be able to create these systems responsibly.
Thanks. Thank you, Zach and Spencer. I'm so glad that we are thinking so deeply about this problem, which is not trivial by any means. On one hand, we want to foster innovation. We want to provide all of the scaffolding and building blocks to developers so that they can build new things. But on the other hand, we are super cognizant of the responsibility needed when harnessing this amount of stochasticity and this amount of power. So thanks again to the Trust and Safety team for building the tools for us.
Thanks for having us.
Thanks a lot.